Hi everybody, it's Miss Caitlin and welcome to your week 1 lesson. I want to give you a couple minutes. Let's go ahead and open our slideshow so that we see this screen. We should see the minions helping us and a blue screen that says electrical circuits and bot building. Alright, now if we have that all up, let's go ahead and let's get started. And I'm going to talk to you through the slides. So you could definitely minimize me if you want. I'll say next slide and then you click next slide. So these are our class goals. We have 4 class goals. We're going to talk about series circuits and parallel circuits. We're going to talk about a motor and how does it work. Then we're going to design our race car and add the circuit. And then we're going to ready, set, go. We'll race our cars and make adjustments. Now today we're going to focus on our goals 1 and 2. So let's go ahead and get started. Next slide. So here's some vocabulary for you on this slide. You'll see the slide with the motor, the circuit, and the minions. The first vocabulary definition that we're going to talk about is a motor. Now in your kit you have a motor, and it's a DC motor, a rotary electrical motor that converts direct current electrical energy into mechanical energy. Now the mechanical energy is what's going to be used to actually propel your car forward. A circuit. We're going to talk about circuits, which is simply a closed path that any electrons can flow on. Then we're going to talk about electrons. These are particles that carry charge through wires in a circuit. And then we're going to talk about voltage. Now your voltage is going to be provided by your battery. You're going to use 2 AA batteries in your battery pack, and that's what's going to provide the voltage to make your car go. And then we're going to say current. Current is the direction that the electrons are flowing. Okay, so now that we read all that, that may be a little bit foreign to you. So let me replace some of these words. From now on, when I say circuit, I want you to think about racetrack, and I'm going to explain why. Also, another word that I'm going to replace is electron. Electrons are going to be called race cars. Okay, so we have race cars and race tracks. Next slide. So for any circuit to work, you need 3 things in your circuit. You need 1, your battery, 2, your wire, and 3, your load. Now in the case of your race car, the load is actually going to be the motor. In this picture right here, we see on the left-hand side this loop. I call this our racetrack. And the reason I call this our racetrack is because a racetrack is simply an oval shape. Now, as long as you can take your finger and you can trace that oval shape and have 1, your battery, 2, your wire, and 3, your load, then your circuit will work. Pretty cool, huh? Next slide. This is a really good demonstration of my race car theory here. I'm going to draw on this slide for just a minute. Now, the direction of current is actually going to be minus to positive. All right? So we're going to come over here. So you may ask, what is current? So let's talk about that. I'm going to use the theory of the racetrack. Now think to yourself, imagine racing on a racetrack. And you're running and running and running. That's what these electrons are doing. All right, so they're racing from the starting line to the finish line. Now, think about it. Have you ever seen a river? Have you ever put something in the water and have it flow in one direction? Have you ever maybe been in the ocean and been floating around, and next thing you know, you kind of floated a little bit further than what you walked out to? Those are all examples of current in the water. Now, electricity is the same. It's no different. It has a direction that it flows. That's all current is the movement of those electrons and where are they going? Which direction are they racing on that racetrack? Now, series circuits, they're the most simple type of circuits that we have. There's no exits. There's none at all. One direction, one path for current. Now, once again, on our series circuit, as long as we have those three things, our battery, our wire, and our load, which in the case of our race cars that we're building is going to be our motor, it will work. I promise you, electricity is super easy. So on our circuits, we have electrons. These are our electrons. These are our race cars. That's what I like to call them. And this is the direction that they're racing. That's our current. All right, so I like to use race track for circuit and race car for electrons. Especially since this is a race car class, huh? That's just my silly minion. So that's next slide. Next slide again. Pop quiz. What are the three things our circuits need to work? Do you remember? 1, our battery. 2, our wire. And 3, our load. Do you remember what the load will be in our race cars? That's right, it's our motor. Now, who remembers what the electron's job is? I think we should talk about it. So let's go to our simulator, and you're getting the full example of my my online class here. So what we're going to do is we're going to go to our simulator. This simulator is going to be available to you in the classroom, and this is how you get to it. When you get to it, your screen will look like this. Now, in order to use the simulator, I want you to go all the way down to right here, Circuit Construction DC Lab. Okay, now we're going to click this button. We're going to click the play button. Let's let our circuit load. Now, the three things that we need for our circuit are available right here. Let's start building. Each circle is a connecting point. When you connect the points, they turn blue. Before they're connected, if they are disconnected, you'll see a red color. You need no additional supplies. Now, class, we have the three things that we need. We have our 1, battery, 2, wire, and 3, light bulb. Let's take a look. All right, and we do see that we have a working circuit. Now, what I want you to notice, take note. Let me see. Take note right here. The blue circles that we see, those are our electrons. Do you see why I call them race cars? Their job is to go from the negative side of the battery, and they race around, and their one job is to light up that light bulb. So they're doing their job right now, and they have a complete path. They're racing from here on the negative side all the way around here through the path that's within the light bulb. Oh, I'm moving our circuit. Through the path in our light bulb and out here. So they're so excited right now, okay, because they're getting electricity from the inside of the battery, and they're traveling and they're traveling and they're traveling. So class, if you've completed these steps, you have now done your very first series circuit. Let's take a moment and pat yourself on the back. Great job, class. Now, when you create your circuit for your car, let's say it does not work. I want you to do me a favor. I want you to check and trace your oval shape or your racetrack and make sure you have complete connections and metal-to-metal contact on your motor. Make sure you have fresh batteries. Make sure your batteries are facing the right way, and make sure you have really solid connections. That's how you're going to know that you have a complete circuit. Okay, so never forget this race car shape that I showed you. I want to tell you about a couple things in this simulator. It is available for you to play with and experiment and do all sorts of things. Whenever you want to disconnect, you're going to press this button and press the scissors. Okay? Your creativity is going to be what the boundary is here. All right? You can do anything you want in this simulator. All right, so you can come in here and you can mimic the design or how the wires are going on your race car. You can connect it, you can test, you can evaluate. There's all sorts of options right here for you to kind of play with. And if you do get to that point, go ahead and send a comment. Let me know where your mind's at and we can help with some troubleshooting and making some really cool circuits. All right. Now let's go back to our minions, and they are going to teach us a little bit more about what we're doing here. Let's see. Current slide. All right. Zoom out a little bit for you. All right, and next slide. So, why do we even use the simulator? Why talk about a series circuit? Well, my friends, that's exactly what we need for our race car to work. We need our battery, we need our wire, we'll have our switch connected, and then our motor will act as our load. This is one complete path for us to travel on, and this, my friends, is a series circuit. So, what is a motor? Does anybody know? Can you think of some examples of motors that maybe you've seen in the past? So motors convert electrical energy from a battery into mechanical energy that provides rotation. Okay, so we know right here that we're going to put our fan on here, right? We're going to put our fan right here. It's a terrible drawing of a fan, but you're going to add your fan right there to the top of the motor, okay? And it's going to spin. So that'll be your mechanical energy that's used to propel your car. So the size of the force, it depends on how fast the motor will spin. All right, so this one here, we're using just regular 2 AA batteries. That'll be your rotational spin. So we have a challenge. And I know everybody likes challenges, but this is a design challenge. So I'd like to ask you, what do you think a good design would be to make your car go super fast? What do you need to do to make it go super fast? What should the shape be? What are the materials? How many wheels? Will you use a fan? Which fan will you use? How many fans should you use? These are all questions that I want you to take a moment and think about. Now, if you have a piece of paper beside you, I want you to start to sketch your ideas. Let's go to the next slide. So there's many designs that you can choose from when you're in this class. There's no right or wrong way to do this, because what we are all scientists. And what scientists do is they experiment. All right, they test and they evaluate their ideas based on observations. You're going to have an observation sheet, and I don't want you to be discouraged. If you get your car together and you're so excited about it and it just doesn't move, don't worry. Don't worry at all. Record your observations on the observation sheet and then ask your questions in the classroom. Say, hey, class, my car didn't move, and this is a picture of it. What do you think that we can do to make this better? Because guess what? You have a whole class full of scientists that you can count on. These are some pretty cool designs that I've seen in the past. And I want to share some more with you. This was a pretty cool car. This was from 2 classes ago that I had this student in. He wanted to include a Nerf gun right here. He did use this propeller-shaped fan. The motor was hooked up here, and he had a switch. It was on the other side. When he turned the car around, you could see it. Now, some issues that he encountered was this was super long, so there was a little bit of a sag right here. There was what we like to call a balance issue. So something that he did to change it is he actually put another set of wheels right here, and that actually helped to keep it nice and even and helped with the balance issue that he had. But this was a pretty cool car. I thought it was a pretty genius design. Pretty proud of him. Maybe you guys might want to sketch something similar. All right, now this one I've seen a couple times. This is just a water bottle. Now, if you do choose to use this design, I want you to remember to put this cap on. Now, if you want, what you could do is keep the cap and try it both ways. Try it with the cap on and then try it without the cap. What do you think would happen if that cap was not on? Would it go faster or would it go slower? What do you think? Okay, class. So the propeller, the car is going in this direction. And what happens is the air is forcing against it in this direction with a cap that's open. So this student decided to leave the cap on. They did use a nice lightweight material. The plastic water bottle, it was very, very light. They ended up upgrading with wheels from their Lego cars. This was the third attempt at the design. Now their switch was a lever switch right here. So they did not incorporate any other switches in their design. But this, when it was demonstrated in the class, it actually went super fast. So it was pretty cool. Let's take a look at another one. So this was a brother and a sister group, and it was pretty cool because the sister was older, the brother was younger, and they both had very, very different ideas. So take a look at this. So right here, they used a straw. The reason they used a straw was because the axle, that metal piece with the wheels that look like this, it was kind of bouncing around, bouncing around, bouncing around. So in order to keep the wheels so that they stopped moving in and out, this student cut a straw and put it right here. And then just poked a little hole into a water bottle cap. And they used a pulley, or a pulley method. So it's like a drive shaft here. And that's what actually propelled their car. So if you see right here, this is that view down there. So that end of the car. Something else I want to point out. I want to point out the cone shape. Now the cone shape is an aerodynamic shape, which means the air flows easily this way. So it cuts through. Can you think of anything that you know about in nature or that exists already that maybe has that shape? What do you think? Maybe an airplane? Maybe a submarine? Good job, class. Now the sail. The sail is a good idea. Now you don't have to use your brand new idea. You can copy any of these ideas. You can look on the internet, and it's okay to think about things that already exist and already know that they work and go ahead and replicate that idea. For example, her brother used this right here, a sail. He was very young and he told me it reminded him of a shark fin. And I said, great. We know that sharks can swim super fast. So now you've taken something from nature that you know works well and you've replicated it into your car. They put the fan on the back of the car so the car moved this way. And these designs both worked very well. This was another example that one of my students have. Now pay attention here, they used two fans. So this top part actually was their first car, and then he wanted to combine it to make it a mega car, or a super bot, I think he called it. So once again, the straws were used to keep the axles from going in and out, in and out, in and out. So sort of provided a little bit more balance there. take a look at another one. Nope. See you next week. All right. So, next week when you pick up, we will talk about the designs that you have. Now let's go back to my slideshow. Let's learn a little bit, or my circuit, I'm sorry. Let's learn a little bit more about series circuits. So I want to talk to you about series circuits. Now, when you have your circuit connected, your motor will spin. And it's very exciting. It's very exciting to first make electricity. Now, another thing that you have in your kit that I want to talk to you about is a switch. So let's take a look at what a switch does. This is my switch here. I'm going to put my switch in. Go ahead and put your switch in on your circuit. Okay, class, now that we've put our switch in, let's talk about it. I want you to think of this switch as a bridge on our racetrack. Anytime that you have an opening, right here, our switch is open, our light is off. Now, take a look at the room that you're in right now. Are your lights on or off? If your lights are off, then the circuit is incomplete. So the circuit is open and your light is off. If your lights are on, then your circuit is complete. Let's experiment. Simply press right here, and your lights will come on. Pretty cool, huh? You just made light. This is exactly what will happen if you wire your switch in on your bot car. That's how a switch works. The electrons can flow. We have a steady bridge right here on our racetrack. Our electrons are doing their job, coming through this light bulb here, going back into the battery, getting some more power, and constantly doing their job around and around and around this racetrack here. This is a series circuit. Great job, guys. Okay, class. So at this point, we have finished week 1. Now, please take a look at my other recordings. What I'm going to do is I'm going to teach you exactly how to use the simulator. I have an additional recording that shows you how to comment on OutSchool. And then stay tuned for our observation sheet and our critical questions that we're going to talk about. Our questions are going to be, what does your design look like? How many wheels are you using? How many motors are you using? What fan did you choose to use? So we're going to ask all sorts of questions and have all sorts of discussion on OutSchool. But for now, I'll see you soon.